Hello, my name is Theodora Ali Shea, and today I will be discussing Lab 3, the magnetic field of a bar magnet. Firstly, the purpose of this lab was to measure the distance dependence of the magnetic field due to a small bar magnet and to compare the measurements to the distance dependence predicted by the Biot-Savart law. The model that we used for this lab was the Biot-Savart law for a dipole as well as the one for a bar magnet. We had to set the bar magnet equation equal to the magnetic field for the dipole on the axis. In addition, we also have the formula showing us the magnetic field of a dipole at any location. The main results of this lab were that as the magnetometer moved closer to the magnet, the measured X component of the magnetic field decreased. In addition, the measured field along the 45-degree axis at a distance of 0.305 meters was equal to 1.75227 times 10 to the negative fifth Teslas, while the computed field along the 45-degree axis at that same distance was 2,130 Teslas. The procedure for this experiment had a system of the phone magnetometer, and the surroundings were everything else, including the magnetic fields due to the bar magnet and due to Earth. The initial conditions had us determine the precise location of the magnetometer on the phone, and then we determined the X component of the magnetic field at various distances from the bar magnet on the axis. We collected our data in the spreadsheet shown and made a graph of the natural logarithm of the X component of the magnetic field versus the natural logarithm of the distance from the bar magnet. Here, my GlowScript model is shown. I had created the magnet at the origin, as well as calculated the magnitude of the magnetic moment. I then created a function to calculate the magnetic field from the magnetic moment and the distance. Next, I created observation locations both on the axis and at perpendicular distances. And I calculated the magnetic fields at each of these observation locations. Finally, I took the perpendicular distance that I measured in the experiment, and I found the magnitude of the magnetic field at 45 degrees at that distance. Here we can see the arrows representing the perpendicular and on-axis magnetic fields, and we can also see the magnetic field at 45 degrees. Some possible sources of error for this lab were that the meter stick shifted a few times and the tapes that were placed on the phone to show the location of the magnetometer fell off. If we hadn't oriented our experiment to compensate for the Earth's magnetic field, we would have had to take into account this equation, which relates the magnitude of the Earth's magnetic field to an external magnetic field, such as that of a bar magnet. And as you can see, it includes taking the tangent of the angle between them. If we were to stick two magnets together end to end, then the magnetic field would be twice as strong in our measurements. Thank you.